So, good evening. Welcome to the week 5 session on the course Integrated Waste Management for a Smart City. I am Abhishek Raj, a PMRF scholar, in the Department of Civil Engineering at Madras. So, we'll start with an outline. The fifth week, we'll give a brief overview of what was discussed in the fifth week, followed by questions of the practice assignment. Then we will discuss some doubts. Yeah. So moving on to the overview for week 5. So the first lecture of this week that was concerned with source handling and separation. So what are the methods of source handling and separation of waste? So such as one of the examples is that different colored bins are used to collect different types of waste such as wet, dry. Then we had collection of solid waste. So what are the methods used to collect solid waste? So there is curbside collection, there is depot collection where everyone deposits their waste at one point in rural areas and then from there it is collected. Urban areas we have curbside collection and other methods. Second lecture was concerned with vehicle routing. So this is related to the previous lecture, which is collection of waste. So when waste is collected, we need to route the trucks so that we can optimally collect the waste in minimum amount of time without much wastage of time. So there are certain guidelines of EPA for vehicle routing, like how should a vehicle travel within the city, what kind of area should it avoid, what kind of area should it use, it should not take U-turns and many such guidelines are there. Then we discussed the global scenario for vehicle routing, like how it is done and different case studies from around the world. The third lecture was concerned with how to check the feasibility of the transfer stations. So transfer station is basically used to reduce the cost of transportation. So instead of like if we have one truck T1, another truck T2, another truck T3. So instead of the fact that all of them go to a landfill and deposit the waste there, it is better for them if the landfill is very far that there will be transportation costs concerned with three trucks. So it is better for them to collect their wastes at a depot. So that is called the transfer station. And from there, maybe big truck T4 can take it to the landfill. It can help minimize the cost. But we need to check if this is feasible to do. And if the distance is very short, it is just better for these trucks to directly take the waste there. So this is usually done when the landfill is too far. Then we have the solid waste generation rates, how to decide at what rates the waste is getting generated so that we can design the system accordingly. Lecture 4 was concerned with the concept of mass balance. So how it is used to design the system of waste management. Then there was backyard composting. The main discussion was around what are the advantages, disadvantages. Also the design of the composter was also discussed. Then we had lecture 5. So here source separation. What is the effect of source separation on the energy content? So if we are trying to remove the recyclables, other wastes from the waste, and then we are sending it ahead to waste to energy plant, so the energy content will go reduce. So how it reduces, how much it reduces, that was discussed in this lecture. Then there were some exemplar problems on the topic of composting as well as source separation's impact on energy content. We'll move on to our practice assignment now. So this was the overview for this week. So question 1. So which of among the following could be an example of the rate of generation of waste material within the system boundary? The given options are wastewater, storage, leachate, biological transformation. So assuming we have a system, so there will be some inputs to the system, there will be certain outputs, there will be a certain storage, there can be some generation within the system. Let us call it plus G. So these all interact together and control the storage. So how will the storage be? That will be the input minus the output. and plus the internal generation. So what kind of generation can happen within a waste management system? So that will be usually due to the degradation of wastes that happen, chemical reactions occur, physical processes are also there. So due to these, there will be a certain generation of waste within the system boundary. This is the system boundary. So here we have taken an example, but usually the system boundary will be the whole city or the municipality where we are trying to design analyze the system. So within the system boundary, if some generation is happening, what will the example of that be? So wastewater cannot be the answer because this will be like output of the system. It can be directly output. Storage is not a rate of generation. This is a block of the system. Storage cannot be the answer. Then we have leachate. Leachate also will be generally like output. As we have seen, landfills generate leachate if not properly managed. And that leachate can contaminate. They will generate leachate in any case, but that should be managed well. So leachate cannot be the answer. So we are left with biological transformation. So that is mainly the degradation of wastes that happen within the system boundary. And that can lead to generation of waste, or sometimes it can even lead to reduction of waste. In that case, the value of G would be negative. So D is the correct answer, that is biological transformation. We'll discuss this using the slide also. So option D was the correct answer, biological transformation. Students can refer to the first lecture of this week. So here we can see the slide for material mass balance. So it is given that storage is equal to rate of material flow into the system boundary. So that is input minus rate of flow out of the system boundary. So that is output. Then we have rate of generation. So let us call it plus G. So once we do this, so storage will come out to be input minus output plus the generation that is happening within the system. So generation can be of, there are multiple examples here. So it can be some sort of transformation. It can be biological transformation or physical also. You can also have some sort of incineration. So that would also lead to transformation of the waste. Moving on to the second question now. So question 2 is a poll. So 10 moles of A were present in a system initially and 5 moles are added to it. And the reaction is given as 2A turns to B. What are the number of moles of B that will be produced as a result of this reaction? Given options are 2.5, 7.5, 15 and 25. I'll drop a poll. You can answer it in the chat also. So I hope you can see the question on the screen, so you can answer it in the chat as well as in the. I have launched the poll. Answer it in the chat also. I'll give you maybe 2 minutes for this. We don't have any response till now. I'll wait for 1 more minute, and we will discuss the answer for this. Anyone has the answer, you can put it in the chat box. So we have one answer in the poll. We'll wait for a few more seconds, then we'll discuss it. So we have another answer in the chat, 7.5. Maybe we'll discuss the answer for this one. Just close the poll. We have been given the reaction 2A is transforming to B. So what can we understand from this reaction? So there are 2 moles of A, so that will form 1 mole of B. So 1 mole of A, that would form half mole of B. So here we can see that initially we were given 10 moles of A, and then we are adding additional 5 moles. So how many moles of A will be there? It will be 10 plus 5. So initially 10 were there, then we added 5. So total 15 moles of A are there. So here we can see that 1 mole of A is getting converted to half moles of B. So if we take 15 moles of A, that would be 15 by 2 moles of B. So that this would be around 7.5 moles of B. So a simple unitary method problem. So the answer is 7.5, option B. So here is the answer. So option B, 7.5 was the answer. So 2A was transforming to B. That means 2 moles of A were producing 1 mole of B. It means half the moles of A would become B. So we were given with 10 moles initially, and then we added additional 5 moles to it. So total number of moles of A were 15. So that 15 moles of A will get converted to 7.5 moles of B. So coincidentally here, the product is also B and the answer is also option. Moving on to the third question. So large containers for waste collection system can be used by which of the following bodies? Given options are high-rise apartments, duplexes, single residences, and low-rise apartments. So quite obvious from the question itself. So here we are talking about large containers for waste collection system. So large containers will generally need when we have higher population in the area from which we want to collect the waste. So for something like a duplex, which is a 2-story building, we won't need a large container. A small bin would be enough. So B cannot be the answer. Single residence, that is a small house, that also won't require a large container. A small bin is enough. So we can remove C also from our list. Then we are left with high-rise apartments and low-rise apartments. So eliminating from the option, so we can see that a high-rise apartment that has more number of floors, more people living in it, it will have higher waste generation per capita. So the total waste generation for the apartment will also be higher. So A is the correct answer. So although D can also have, D will also have a container requirement, which will generally be higher compared to option B and option C. But given the options here, so among high rise and low rise, we can go with high rise apartments for large containers for the purpose of waste collection system. So we'll see this. So high rise apartments, students can refer to week 5, lecture 1. So who gets curbside pickup? That is, the vehicle would come and collect from your house, in front of the house at the backyard itself. So that will be single residence, duplex, low-rise apartments, and medium-rise apartments. But when we talk about large storage containers, this will not be generally curbside. There will be a designated place for the waste container where either someone or the people go and deposit there, or there will be a personnel for them, designated personnel who will collect the waste from all the houses and then he will go and put it in the large storage container. So this is done for medium-rise apartments, high-rise apartments, and commercial and institutional places. So quite obvious, commercial and institutional places will have more waste generation because more people are using the facility, so they will require large storage containers. Moving on to question 4. So this is a poll, and this is also a numerical. So determine the number of houses in a colony with an average occupancy rate of 4 people per house that generates 3 containers, and the volume of each container is given as 7.5 per week after compaction. So waste generation rate is given as 0.45 kg per person per day, and compacted specific weight is 300 kg per meter cube. Given options are 425, 536, 200 and 150. So I will drop a poll and try this out. So I'll give you around 2 to 3 minutes for this, since this is a numerical. It's question 4. 4 options we have here: A, B, C, and K. So the poll is live. You can answer it in the poll as well as the chat. Do we have any answers till now? So we don't have any answers of yet. I'll wait for 2 more minutes, then we'll discuss the solution. So anyone who tried it, you answer it in the chat. No issues if you are even getting something different from the options. You can put that also. It is also. Someone who's voted in favor of option A. Okay. Few more seconds, then we'll discuss the answer. Okay, maybe we'll discuss the answer for this now. Learn the poll. Okay. So there is a lot of information in here, so let's not get confused with that. So just draw a simple figure to understand what it means. So we have the colony. So the colony will have multiple houses, and each house will have number of people. So there will be an average occupancy rate for each house. So depending upon this, the waste will get generated. So that will be collected in the bin. So here we can see we don't know the number of houses in the colony. So that is the variable we need to find. So let us call it as n. So let us say that is n. Then number of houses in a colony, average occupancy rate of 4 people per house. So each house has 4 people. That means 4 into n people live in the colony. And then each person will generate some waste. That is the per capita generation rate. So that is given here as 0.45 kg per person per day. So 0.45. So this would be the waste that is generated from the colony in one day. Okay, so yeah, so this is the per day generation of waste. This is the per day generation that will be happening. Then on the other side, we will have the waste that is getting collected. So here we have 3 containers and each container volume is 7.5. So 3 to 7.5. This will be the volume of waste generated. And we will need to convert this volume into weight because here we are taking the units in kg. So how is weight obtained from volume? So that weight will be density into volume. So density is given here as 300 kg per meter cube for the waste. So this was the volume and density will be 300. So this much waste is getting generated per week. Week is the keyword here, we should not miss it. So every week this much waste is getting generated, and on the left side we have waste generation of one day. So how will we go from a day to a week? So this will operate this with 7. So each house had 4 people. 4 people were generating 0.45 kg waste per day. So from the whole colony, since the colony has n number of houses, that is what we need to find. So this much will be the waste generation per day. Then we'll operate it with 7. So this would give us n equals, this will be 22.5 into 300 divided by 28 into 0.45. This would turn out to 300 into 22.5, that is around 6750 divided by 28 into 0.45, so that is 12.6. So 6750 divided by 12.6 is coming out to be 535.71. So we can round it off since it is number of houses. So this should be an integer. It will become 536. So this much number of houses are there in the colony, which will need 3 containers of 7.5 meter cube. It should be compacted at a rate of 300 kg per meter, given the waste generation of 0.45 kg. So option B is the correct answer. Moving on to the solution. So option B is the answer, 536. Students can refer to the 4th lecture of this week. So we were given the number of containers, 3. Each container's volume was given, 7.5. The compacted weight was given. So from that we can find the amount of waste that was generated per week. So that would be 3 into 7.5 into 300. So that would give out to be 6750 kg per meter cube. Sorry, kg per week. And then this we can divide by 7 to find the waste generated per day. We can divide it by the waste generated on a house level. So that will be 4 into 0.45. Similar solution, just from a different approach. So I have solved using one approach, and here I have mentioned another approach. So you can adopt whichever is comfortable to you. Moving on. So question number 5. So which of the following data is required to design a solid waste management system? Quantity of waste generated, quantity of waste collected, and quantity of waste separated, and all of the above. So when we are designing a system, so a system is nothing but a combination of inputs and outputs. The system will be basically a mathematical model of how it is changing the input into output. So we have certain inputs, we have certain outputs. There will be certain storage, as we saw. There can be some generation within the system. So here we are talking especially with respect to solid waste management system. So here there will be certain waste generation within the system boundary. So that is G. There will be certain waste collection. So what will happen to the collection? So basically that will go out of the system, or even that can come into the system. Like we can collect from different places and put it into the transfer station, which may be within the city. So that will be an example of collection. But usually collection will be which is going outside. That will come as output. Then we have waste separated. Separated waste, multiple things can happen with it. It can go into recycling. It can be kept for storage also for further use, like plastics, aluminum, those things can be kept. It can go in the output. So all these three, generated waste, collected waste, separated waste, all these three will be needed in some form or the other while designing this solid waste management system. So all the data for all these three will be required for the design. So A is correct, B is also correct, C is also correct. So the answer will be all of the above. It is option D. Moving on, we'll discuss this. So option D was the answer, all of the above. Students can refer to the third lecture of this week. So knowledges of the quantities of solid waste generated, separated and collected is fundamental to the design of solid waste management system. Move on to the next question, that is question 6. So 20 moles of carbon react with 40 moles of hydrogen gas, and how many moles of methane will it produce? That is CH4. The given options are 5, 10, 15, and 20. So let us, we need to first form the equation. So similar to the previous question where 2A was turning into B. So here we need carbon, we need hydrogen, and we need methane as the product. So now we will need to balance the equation. So here we can see there is 1 mole of carbon here, 1 mole of carbon here, so that is balanced. Then we can see here we have 4 atoms of hydrogen, but here we have only 2 atoms. So we'll operate this with a 2. So now it is 4 more atoms of hydrogen, 4 atoms of hydrogen on the both reactant and product side. And we should also check the carbon again, because here it does not matter because there are only 2 components. But if it is a complicated reaction with balancing, the number sometimes changes. So still carbon is 1 mole, 1 mole. So reaction is balanced now. So 1 mole of carbon reacts with 2 moles of hydrogen, and this will form 1 mole of methane. So who is the the controller here for the reaction? That is carbon, because that is the minimum amount, and whatever is the minimum amount, that much methane will only be formed. It does not matter if we supply 4 moles or 8 moles of hydrogen, because carbon is the constraint here. That is only 1 mole, so only 1 mole of methane will be formed. So always carbon will constrain the reaction, because that has the least amount in the reaction in terms of number of moles. So 1 mole of carbon will give 1 mole of methane. So here we have 20 moles of carbon, and we are supplying sufficient hydrogen, 40 moles. So how much ever carbon we have, 2 times hydrogen we supply at a minimum. So 20 moles we had, so 40 moles we have supplied the minimum that is required as per the reaction. So how much methane will be formed? Simply 20. Because 1 mole of carbon was forming 1 mole of methane. So 20 moles of carbon will form 20 moles of methane. So the answer is option B. Moving on to the solution. So the balanced chemical equation is C plus 2H2 will give the methane CH4. So here we can see 1 mole of carbon will produce in 1 mole of methane. So for 20 moles of carbon, 20 moles of methane will be produced. So the next question is question 7. So here we have been given the system. So we have an input of 1.5, some storage, and output. There are 2 outputs. streams. So one is the stream for recycling, that is 1.25, and another is the mixed waste 0.1725. So we need to calculate the internal storage, the mass balance of the materials. So the given options are 0.07, 0.77, 0.05, and 0.06. So as we saw in the one of the cases, so storage is nothing but input minus output plus generation. So storage we need to find here. So that is the variable. Calculate the internal storage. So S will be our variable. We have been given the input. So 1.5 output. We have two sources of output. So let us substitute the values. So that will be 1.25 and plus 0.1725. So two sources, two values, and plus generation. Here we have not been given with anything, so let us assume the generation to be 0. There is no system generation within. There is no generation within the system. So let us do this calculation. So 1.5 minus 1.25 minus 1.1725. So this is coming out to be 0.0775. So we simply subtracted the output from input, and that gave us the storage. Here, because there is no generation, if there was some generation, we would need to add it. So the answer is option A, that is 0.0775. So answer was 0.0775. Students can refer to the fourth lecture of this week. Change in storage is nothing but inputs minus outputs. So 1.5 was the input and two output sources were there. We subtracted to get the answer as 0.077. So the next question is a poll. That is question number 8. So here we have been given the figure. So this is the figure for checking the feasibility of transfer stations. So name the missing point in the graph given below. So point of intersection, break-even distance, breakout point, and odd-even ratio. So what is the missing point here? So I'll just highlight it. So this is the missing point. So where the red line, number 1 line, is intersecting with the number 2 line. So the point of intersection is what you need to name. So you can answer it in the chat as well as the poll. So I will drop a poll. So this is question number 8. Option A, B, option C, option D. This is question 8. You can answer it in the chat as well as the polls. So someone has answered B. Wait for 1 more minute and then we'll discuss the answer. I have one response in the poll as well. Maybe we'll discuss the answer to this now. So yeah, so we need to find the missing point here. So we don't need to find it. We just need to name what is it. So this is the feasibility of transfer station graph. So the first line, that is the red line we can see. So that is the direct haul option. So that is we collect the wastes using different trucks, T1, T2, T3, and all wastes we take it to a central landfill. This is first option, direct haul. So here, since the more trucks we have, the more mileage it will be. With more mileage, the costs will go on increasing. So it will start with 0 and will go on increasing. But what we want to do is we want to construct a transfer station now. So we'll give a transfer station here, and that from there, a larger truck will take it to landfill. So because we are constructing something, so there will be a capital investment involved with this. So there will be an initial cost here. So there will be an initial cost. So it can be any value depending upon how much it is taking, what is the size of the transfer station. And then depending upon that truck's cost. So since it is a larger truck, so costs will be economical because it will transfer more waste at a time. So that you can see that the slope of the green line is comparatively lesser compared to the direct haul line. The rate of increase of costs for a larger truck will be lower. So the point at which they intersect will be called the break-even point or the break-even distance. Since we are projecting here on the x, so x-axis is the distance, so here we will call it break-even distance. So it means that there must be this much minimum amount of distance so that the option of building a transfer station is more lucrative than direct haul. So initially what is happening is, so here we can see, just clean this graph. Okay, just clean now, yeah. So let us consider two stages. So let's call this stage one. Let's consider here stage two. So here we can see that direct haul, the cost is cheaper compared to that of the transfer station. So here it is better to just do direct haul. When compared to stage two, so here direct haul is expensive compared to uh, the construction of a transfer station. So here it is better to do transfer station. Here it is better to do direct haul. So what decides this? This point, break-even distance. So after this, we'll go for a transfer station. Before this, we should go for a direct haul, depending upon the costs. So the answer is option B, break-even distance. So break-even distance was the answer. Students can refer to the third lecture of this week for the solution. Moving on to the next question, question 9. So this is a true-false question. So intermunicipality transport leads to diverting the waste from landfills. So true and false. So just a simple question. So let us consider two municipalities. So let us call it M1 and M2. So what is happening here is, so let's say M2 has its own landfill, and M1 also has its landfill, but M1's landfill is, let's say, L1 is smaller than L2. So what will happen is, if the amount of waste generated is exceeding at a higher rate, or there is sudden generation of waste due to some cultural gathering or any such thing, so M1 will need to reroute the waste to M2 because, and there will be inter-municipality coordination for this. So instead of sending it to their own landfill, they can reroute it since the landfill at M2 is larger. And they will accept it sometimes, sometimes they may not accept, depending upon how is the relation between the municipalities. So intermunicipality transport, when we are doing our waste, that leads to diverting the waste from the landfill. So here, generally it would have gone to L1, but instead of that, it went to L2. So answer is true. So answer is true. Students can refer to the third lecture of this week. So here we can see how people divert waste before it gets collected. So backyard composting can be done. There can be reuse programs and there can be intermunicipality transport. So disposal in other jurisdictions, one of the examples. So the next question is question 10. Which of the following are different methods of estimation of the quantity of waste generated? Given options are energy balance, material balance, load count analysis, and weight volume analysis. So estimation of quantity of waste. So the one first method, that was load count analysis. So that is basically depending upon the compaction density, number of trucks, and the per capita waste generation that is done. So this was discussed in the last week, that was week 4. Second method is for the estimation of quantity that we saw in several of the previous questions. So that is storage is input minus output plus generation. So what is this? This is mass balance. So this is another method that is done. And third is weight volume analysis. So every element in the waste will have a certain density. So depending upon the volume we are collecting, because it is relatively easier to measure volume from operating it with the density, we can find the weight of the waste. So here multiple options will be correct. So material balance, load count analysis, and weight volume analysis, B, C, and D are correct. So the correct answers for this are material balance, load count analysis, and weight volume analysis. Students can refer to the third lecture of this week for this question. So here we can see we need the knowledge of waste generated, separated, and collected for the design of the solid waste management system. So this we also discussed in one of the previous questions. So once we know how to design, so we need to, before designing, we need to estimate the quantity of how much waste is being generated. So that is how we use these three methods, that are material balance or mass balance, weight volume analysis, and load count analysis. Moving on to the next question, that is question 11. So this is a poll. So curbside pickup is a source handling and separation method of solid waste. Given options are true and false. So you can answer it in the chat as well as the. I'll just drop a poll quickly. You can take maybe a minute for this. This is question 11. Next option is true. The poll has been launched and you can answer it in the poll as well as the chat. So we have one response in the poll. I will wait for maybe one more minute and then we'll discuss the answer. If anyone else wants to respond. Any more responses? So no responses in the chat. I just check the polls. So one response in the poll. Someone has said true. Okay, I'll end the poll. We'll discuss the answer now. So here we are talking about curbside pickup. So what we do is that in this is, so we have houses. So there will be the roadside. So the waste collection vehicle that will come here, collect the waste from house one, move on, will collect the waste from house two. So depending upon this, it will go on moving. It will collect throughout the colony, and however their plan is, they will collect. So this is the curb, road curb. So on the curb side, we'll collect the waste. So this is not a handling and separation method. No, this is not. This is a collection method. Handling and separation will be when we are trying to separate the wastes. So there will be different things like sometimes we'll do wet dry, sometimes we will do bio, non-bio, sometimes we'll do like recyclable and non-recyclable. So different themes are there. So that is how we handle or separate the waste. But curbside pickup is not one of those. That is a collection method of how we are collecting the waste. So another example we saw in one of the previous slides. So there we use large containers. So the answer for this is false. It's a collection method, not a handling and separation method. So the answer is false. Students can refer to the first lecture of this week. So here we can see the handling and separation methods have been mentioned. So we separate the recyclables, we can separate the compostable materials, we can operate a backyard composter. So that will be handling, not separating. So separating is when we are trying to differentiate between different things. So here we are separating, here we are separating, then we are separating reusable products, then we can drop off the household hazardous waste also. So that is also one. So these are basically handling, and the others are in separation category. So curbside pickup is a collection method, not a handling and separation. Moving on to the next question, that is question 12. So which of the following are the advantages of backyard composting? Provides stabilized material for gardens. Mulching in backyard composting improves the recycling rates. They attract pests and flies, and can also use meat from food waste in the composting. So here we are talking about backyard composting. So compost is nothing but a kind of organic fertilizer. So it is used for stabilization in gardens. So certain ratio, it will be mixed with soil and it will be used. So the first option is correct. So that is the advantage of compost. So it provides a stabilized material for gardens. So they attract pests and flies. So this is not an advantage. This is rather a disadvantage of composting. So if not properly done or not properly packed, the compost is not properly packed. So it can attract these pests and flies. Quite obvious because degradation is happening. So this is not advantage. This is a disadvantage. So this we can remove. Then we have, can we use meat from food waste in the composting? So no, we cannot use meat because the degradation time for meat will be higher compared to other waste such as yard waste, leaves, food waste. So not food waste, like vegetarian food waste. So from that meat, so the life should be very similar. So that is good for composting. So meat we cannot use. That is also a disadvantage, or we should not use. So that more like a demerit for the composter. So D also we can remove. So finally we are left with B. So B is mulching in backyard composting improves the recycling rates. So mulching is nothing but when grass or leaves they die. So instead of doing anything, so we'll just like try to fragment them, segment them into smaller pieces, and we'll spread them over the soil. So with time they will get degraded and mixed up with the soil. So that improves the recycling rates. So that is called as mulching. So basically the grass and leaves, they will be mixed with soil again. So instead of directly composting them, so that also we can. So that is option B. So B is also correct. So A and B are the correct answers. So which are the advantages of backyard composting? So students can refer to the fourth lecture of this week for this question. So here we can see we cannot use any meats. It attracts pests and flies and takes a long time to break down. So some cities may require residents to compost leaves, so which are example of yard waste. So advantages are stabilized material for gardens, but a disadvantage will be it can cause odor problems, and mulching is also considered as a composting example. So it is like an indirect composting. So it's excellent for recycling the yard waste. So this was the last question for today's session. If anyone has any doubts, you can ask, or else please feel free to leave. I hope you found the session useful. If you have any doubts, you can ask. I will wait for 2 more minutes and then we will close the session. If anyone has any doubts, you can ask. If anyone does not have any doubts on this, and so we'll close the session now. Thank you for attending.